Hey guys, let's discuss new problem from binary tree, which is find whether the tree is balanced binary tree or not. So the definition for it is very simple. If the left subtree height and right subtree height difference is greater than 1, then they are not balanced subtree. Okay. So for example, let's see, this is your tree 1, 2, 3, okay, 4, then 5. Okay. So here if you check, what is the height of the left subtree? Is it 1, 2, 3, 4? Okay, and what is the height of the right subtree? It is 2. So 4 minus 2 is 2. So this is not balanced binary tree. Okay, let's say if I create here one more variable 10. Okay, in that case the height will be 3. Okay, and then 4 minus 3 would be equal to 1. So it is not greater than 1. So this is balanced binary tree. Okay, so this is how you need to find in this question. This is what you need to find in this question. So let's take the what is happening in the code. Okay, we will be using recursion, and I have explained many dry runs related to recursion. So see what is happening here. You will be given a root node, okay, and then you need to check whether it is a balanced or not. So how you will check it? You will just run this check height function, and whatever it will return you, if it is returning you -1, okay, so -1 is not equal to -1, so the condition will be true, and this will be your answer. Means the condition will be false. -1 is not equal to -1, condition will be false. Okay, so this one will not be your balanced binary tree. Now what is happening in check height? So in check height, see, if node is equal to 0, return 0, because that will be your base condition for the leaf nodes, right? For the leaf node, what will be the height? 0. So that's why you're returning here 0. Then you're running the same function, recursive function, for node dot left. Okay, it will return you the height of the left subtree, which you will store in left height, and then you will check if left height is equal to -1, then to return directly -1. Okay, otherwise you will check for right height. Okay, same check for right height also. If it is -1, return -1. Otherwise, see, you found the left height and then right height. You have left and right height. Okay, what you will do with this, you will find the difference. Okay, and if difference is greater than 1, then return -1. Okay, so you understood how this -1 was coming here and why we were checking for -1. So we have added this condition that if the difference is greater than 1, then return -1. Okay. Okay, if difference is not greater than 1, in that case, what you will do? You will return 1 plus whatever is maximum. Okay, left or right. You're returning the height, right? That's why. So you want me to dry run it? So it's already 3 minutes. Okay, let me dry run. So actually the thing is, in YouTube, if the video size is greater than 3 minutes, then it will not consider it in a short video. But that's okay. Let me dry run it, okay, for you. So let's say your tree is something like this: 1, 2, 3, and 4. Okay, and here you have 5, 6. That's it. Okay, so this one will be balanced, 4 minus 3. Okay, so let's run this function. Let's run this check height function, ch function, for tree node, which is 1. Okay, something is happening here, you're finding left height equal to check height for 2. Okay, left height, node left. Then what is happening in check height 2 function? Left height will be equal to check height. This one will run for 3. Okay, now what is happening in check height 3 function? 3 will be root here, so left height equal to check height 4. Okay, now what is happening in check height 4 function? So left height equal to check height null. So what null is returning you? 0. So you will get here 0. Now what is happening next here? It is checking if left height is equal to -1, return -1. No, I'm getting 0, so it's okay. I will now run this function for right height. So right height equal to check height for null. Again, it will return me 0, and this is not -1, so I'll not return -1 as well. So now I'll find the difference between both. 0 minus 0, okay, will be 0 only, and which is not greater than 1. So I'll not return -1, and what I will return? 1 plus whatever the maximum height. So I will return 1 from here. Okay, this one, where it will go? From where this function is getting called. This function is getting called here, so 1 will come here. Okay, now after this, left height is not greater than 1. Okay, so I will not return -1. So now I will run the same function for right height. Okay, which will running the check height node ka right. So node is 3, so 3's right is 0, null again, so it will return me 0. Okay, so 1 minus 0 is 1, and which is not greater than 1, so I will not return -1 here. Okay, using this condition, so this condition will not run, and then I will return 1 plus whatever the maximum height. So 1 plus 1, I will return 2. Where? Here. Okay, can I remove all this code? I don't need it right now. Okay, so this one will get returned here. Now here this is 2. Okay, this is 2, so it is returning me 2. What height of the 2, right? Second node. so it is returning me 2. So left height will 2. Now check height will be, yeah, so left height is not equal to -1, so I'm not returning -1. Now I will check for right height. Okay, RH equal to CH. It will run, right height will run for node ka right, so node was 2 and node ka right is null, so it will return me again 0. Okay, so now just find the difference. 2 minus 0 is greater than 1. Yes, condition true, so it will return -1. So it will return -1. This -1 will come here. Okay, and here it will check left height is equal to -1. Yes, so it will return -1 from here itself. So this tree is not balanced tree. Okay, initially I told you that this tree is balanced tree, but this is not, because it should satisfy this condition that left subtree, right subtree height should not be equal to greater than 1 at each node. Okay, if any one node, if it is failing, then this complete tree is not balanced tree. Okay, so it was failing here on second node, right? The tree height here is 2 and here it is 0. 2 minus 0 is 2, which is greater than 1. So that's it. Thank you.